What's poppin', dogs? Mr. Allen here. We're about to graph this dope rational function f of x equals 1 over x squared plus 6x plus 5. But first things first, we got to factor that denominator. Oh, love when we got to factor, bro. So I got to figure out what multiplies to 5 and adds to 6. That's going to be 5 and 1. So now what I'm going to have is f of x equals 1 over x plus 5 and x plus 1. Boom! We are in factored form. We are ready to rock. Now, I got two factors in my denominator. That's going to give me two vertical asymptotes since there's nothing in the numerator to cancel with one of those, creating a whole. So all I'm going to do here is set those two equal to 0 and solve. And I'm going to get vertical asymptotes being x equals -5 and x equals -1. Let's plot them up. We got -1. Whee! Boom. We got -5. Oh, yeah. Beautiful. Now, how about horizontal asymptotes? What about horizontal asymptotes? Sorry, asymptote. You wouldn't have two of them. I can't pluralize that. Well, since this one doesn't move up or down, there's nothing added or subtracted out here, right? And since my degree of my numerator is smaller than the degree of my denominator, it's a degree of 0 up here, degree of 2 right here, it's going to be y equals 0. So I'll go ahead and, boom, dash that bad boy up. Beautiful, fantastic, wonderful. We've got ourselves a dope graph here. I'm going to do one more thing before I start graphing, all right? I'm going to find my y-intercept. I think this is a pretty easy thing to find and very common across many graphs. It's the same concept every single time. If it has a y-intercept, how do we figure it out? Well, we would want to set my x value equal to 0. Because if my x value equals 0, it's going to be crossing the y-axis, right? My x value of 0 is right here, so then it lies somewhere along that y-axis. So if I plugged in 0 for x, I can either do that in the factored form or in the original form. And actually, I think the original form is going to be easier here. 0, 0, and I'm left with 5, so it's going to be 1/5. If I did that in the factored form, I'd get 0 plus 5 is 5, 0 plus 1 is 1, 5 times 1 is 5, 1 over 5. But again, it was easier in that one right there. Just like with polynomials, it was always easier to find your y-intercept when it was in standard form. Same kind of thing goes here. All right, even if I have stuff going on in numerator and denominator. So I'm going to plot that 0 and then 1/5. So this tells me for sure that this graph exists right here, follows along that horizontal asymptote. The next thing that's going to happen is it is going to be right here. We can also test a value if you'd ever like to. We don't have to right now. Again, we're in the basics of rationals right now, as crazy as it looks. There's more to them, and we'll add as we go, right? I could have plugged in some, random x value here into this thing, and I'll get some kind of ordered pair in there. But generally speaking, with rationals, we want intercepts, right? Holes, and all that good stuff. Then, got that last guy right there. Woo! That is beautiful. Now, let's see here. Let's get ourselves some domain and range. All right, so domain. Domain is going to be my x values. That's what I want to look for, right? All real numbers for polynomials, but once we get to rationals, now we got to exclude some values. My vertical asymptotes are those guys that I exclude. If I'm looking at an equation and trying to find my domain, it comes from my denominator. How convenient. Domain, denominator, both start with D. So since my two asymptotes are x equals -5 and x equals -1, I'm going to have x does not equal -5 and -1. Boom. Easy as that. So now on to range. And actually, for range, I'm going to hold off on this one here because it takes a bit more to figure out your range because we don't know how high up this middle part of the graph goes. So we're not only omitting that 0 value from that, we'd have to take out our calculator, find a maximum here, and then go from there and omit those values. So for this one, since we're keeping it basic, we're going to avoid the range on this one. It is doable, but we're just not going to cover it in this particular video, all right? Sorry to get your hopes up on the range. All right, let's see what else we want to do here. How about end behavior? Let's get some end behavior action going on. So end behavior, as x approaches -infinity, as I go to the left side of the graph, my graph is approaching 0. So I'd have f of x approaches 0. And as x goes to positive infinity, as I go to the right side of my graph, we got f of x approaching 0 as well. How about some behavior around my asymptotes, man? I'm running out of colors. I'm going to go back to pink for this one. So around my asymptotes, I got two vertical asymptotes that I got to discuss here. First one's at -5. So as x approaches -5, but from the left-hand side, so from this side of the asymptote, it is going whoop, way up there, man. We're going f of x is approaching infinity. Beautiful. Wonderful. Now, how about as x approaches -5 from the right-hand side? So from this side of the graph, I'm looking at this section, it is going down to -infinity. From this side, as I get closer to -5, my graph, the blue part, is going down to -infinity. So f of x approaches -infinity. Another asymptote at -1. So as x approaches -1 from the left, again, we'll go from the left first, f of x is approaching what? Well, as I approach from the left side, right, here's my asymptote. On this side, as I approach from the left, this graph is shooting down. We're going to -infinity. And then lastly, as x approaches -1 from my right-hand side, what's f of x doing? F of x, let's see here from the right-hand side, we're going whoop up to positive infinity. Man, that's some stuff right there and some things, man. We got ourselves our y-intercept. We got some domain. We avoided range on this one. It is doable. I promise. We'll do it another time. We got our vertical asymptotes, horizontal asymptotes. You know, end behavior's dope. Behavior around our asymptotes. All dope things, man. And we got the factor. That's a bonus for that one. We got the factor. That's awesome. All right. You guys have yourselves a wonderful, wonderful day. Make sure to like and subscribe, as the YouTubers say. And have a dope day. See ya.